Okay, good afternoon, student. Today we are going to continue our lesson with part of substituted benzene. Okay, we already study about the first, second, and third substituted benzene. Now we are going to continue with the reaction of some substituted benzene, which is arena, phenol, and halobenzene or aryl halide. What is arena? Arena is a hydrocarbon consists of an aromatic and aliphatic compound. An example of arena is alkylbenzene, styrene, and any organic compound which having two type of organic compound, an aromatic, or the simple one is benzene, and an aliphatic compound. Okay, in alkylbenzene you can see that there are carbon that attach directly into the benzene ring, and this called with the benzylic carbon. And the benzylic carbon is more reactive than usual alkyl carbon. For example, in ethyl benzene there are two carbon here. The first one that attached directly to the benzene ring is called benzylic carbon, and this is more reactive than other carbon. Okay, this is some example of structure and nomenclature of alkyl benzene. This is toluene or methyl benzene. The second one is ethyl benzene. This one is normal propyl benzene. This is the isobutyl benzene, and benzene structure having two methyl groups are called as a silane, and if the second methyl group attached in the ortho position, then it's called as orthoxylane. And when the methyl group is attached on the meta position, it's called as metaxylane. And of course, when the methyl group attached in the para position, it's called as the paraxylane. How we can prepare the alkyl benzene? As you already studied before, the alkyl benzene can be prepared by alkylation or attachment of alkyl group by Friedel-Crafts alkylation. Or also the alkyl benzene can be prepared by the Clemmensen reduction. The Clemmensen reduction is a reaction of phenyl ketone or aromatic ketone in acid condition or basic condition to convert the ketone into alkyl benzene. But remember, you can see here that the alkyl benzene produced by the Clemmensen reduction is a long chain alkyl benzene, so it is impossible to produce for example methyl benzene or toluene by the Clemmensen reduction. Okay, next we are going to study about some alkyl benzene reaction. So there are four basic alkyl benzene reaction. The first one is hydrogenation, the second one is oxidation, and then the side chain substitution or free radical halogenation, and the ring substitution or aromatic electrophilic substitution. Okay, now we start with the next or the first reaction. It is a hydrogenation. In hydrogenation, you can see here For example, this is ethyl benzene, and the hydrogenation of alkene benzene can be conducted by using catalyst, nickel, platinum, or palladium. Just choose one of them. You can choose nickel, platinum, or palladium. What is the product of the alkyl benzene reaction, hydrogenation? The ethyl benzene is converted into ethyl cyclohexane. Here you can see that the double bond of carbon atom is cleavage into the single bond atom carbon. Remember, this reaction needs high pressure. So the ethyl benzene will be converted into ethyl cyclohexane. There will be the cleavage of or the reduction of the double bond carbon atom into single bond carbon atom in the benzene ring. Okay, and so what happens if we reduce the styrene using the hydrogenation reaction? In here, styrene having many double bond carbon. There are double bond carbon in benzene ring and also double bond carbon in alkane group. Okay, so what happen if there is a hydrogenation reaction happen in the styrene? The double carbon in the alkane will be converted into single bond. This happen in mild condition. So in mild condition, it is not possible to cleavage or to reduce or to convert the double bond carbon in benzene ring into cyclohexane. So in case of styrene, the hydrogenation, only cleavage of double chain carbon in alkane. I mean, not in benzene ring, but in the alkane ring. Okay, so if you continue the reaction with high pressure, then it is possible to convert the ethyl benzene into ethyl cyclohexane. But if only mild condition, then the styrene will be only converted into ethyl benzene. Okay, the next reaction is oxidation. Oxidation of alkyl benzene will produce carboxylic acid. So, oxidation of alkyl benzene is conducted by using the hot calcium permanganate to form a carboxylic acid, what we call with benzoic acid. So, all the alkyl benzene oxidation will with calcium permanganate will produce the benzoic acid. Okay, all the side chains of aliphatic compound oxidized by hot calcium permanganate will produce a benzoic acid. Okay, the question is, what are the products when orthoxylene, methoxylene, and paraxylene are oxidized with calcium permanganate? Remember, what is xylene? Xylene is a compound where two methyl groups are attached in benzene ring. So what is the product? when orthoxylene, methoxylene, and paraxylene oxidize with hot kalium permanganate. Okay, remember all the aliphatic compound or the side chains of methyl here will be oxidized into carboxylic acid. So in orthoxylene, we'll have two methyl group attached in the ortho position will be converted into two group of carboxylic acid here, which call for orthoxylene. The product is named as a phthalate acid, and for methoxylene there will be converted into the isophthalate acid, and the paraxylene is converted into terephthalate acid. Okay, so remember, any kind of aliphatic group attached in the benzene ring or as a side chains will be converted into carboxylic acid, COOH or COOH. Okay, is a carboxylic acid group. Okay. Okay, in halogenation, there will be two type of halogenation. So halogenation can happen in the benzene ring and or in side chains. If the alkyl benzene react with halogen at hot condition or the presence of ultraviolet, then the reaction happen at the side chain or alkyl group. But if the alkyl benzene react with halogen with the presence of catalyst, ferric chloride or aluminum chloride, remember what is the reaction? This is a usual halogenation reaction, and they will produce the second substitution. This is the side chains, and this is the benzene ring. The substitution in side chains happen when the reaction is added with a catalyst of aluminum chloride or ferric chloride. So the reaction will be halogenation substitution. But when the reaction is with ultraviolet or with heat, then the reaction is in a side chains. Okay, so side chains happen with ultraviolet or heat, but in benzene ring happen with catalyst of aluminum chloride or ferric chloride. Okay. Further, the coordination, for example, for side chain can happen not only in monohalogenation but also can happen in double halogenation or even triple halogenation. For example, toluene can react with chlorine with the heat and ultraviolet to produce benzyl chloride. And the next chlorination with heat or ultraviolet produce benzyl chloride, and then following halogenation reaction with ultraviolet or heat will produce the last product, what we called with benzoyl trichloride. Okay, but for ring halogenation can happen with catalyst. In this case, the catalyst is ferric chloride. Then the reaction will follow the usual second halogenation. Remember, for second halogenation, because the group already attached in the benzene ring is a methyl. Methyl is an alkyl group, and the alkyl group will result on the ortho and para substitution. Okay, compared to the other carbon. The carbon benzylic has the benzylic hydrogen that's more reactive compared to the hydrogen, the other than benzylic hydrogen. Okay, for the benzene ring substitution, I think it's similar to previous one, which is the it depends on the group. It is an activating or deactivating group.